All right, so we're diving deep today into this paper. It's called Unleashing the Potential of Large Language Models for Text-to-Image Generation Through Autoregressive Representation Alignment.
Wow, that's a mouthful.
Right.
But honestly, the title is not exaggerating at all. This paper is about using LLMs, and you've probably heard of these. They're the brains behind a lot of things like chatbots and stuff like that. And it's using those to create images from nothing but text descriptions.
Yeah, so I'm picturing like typing in, a cat wearing a monocle, riding a tiny bicycle through a field of sunflowers, and then boom, the AI just like paints it for me. Is that kind of what we're talking about?
Exactly. But there is a catch, and the researchers spell it out. They're from the Chinese Academy of Sciences and the University of Hong Kong. LLMs are built for language, which flows in a line, word after word. But images are a whole other beast. They're all about spatial relationships, like understanding how all the parts fit together visually.
So you're saying that getting an LLM, which is used to thinking, one word at a time to grasp the complexity of an entire image is a pretty big hurdle.
It's a challenge for sure, but that's what makes this research so exciting. Instead of, redesigning the entire LLM, they figured out a way to kind of work with what we have already. Using a clever approach they call autoregressive representation alignment, or they shorten it to ARRA.
Okay, hold on. ARRA.
Yeah.
Break that down for me. What's the big idea?
So imagine this. You've got like an LLM student who's brilliant with words, but they really struggle with visuals.
Okay.
So you bring in, an expert art tutor to kind of guide them. That's essentially what ARRA does. It uses external AI models that they're calling foundational models that are already masters at visual understanding.
Got it. So instead of teaching this LLM to see from scratch, they're tapping into AIs that already have that skill.
Exactly. They use models like CLIP, which is really good at connecting text and images, or MedSam, which is specifically trained on medical images. It's like choosing the right tutor for the subject you want to learn.
Oh, okay. That makes sense. So then how does ARRA actually guide the LLM? Like, how does that learning actually work?
That's where it gets really neat. They introduce a special token called HYBNEXT. Think of it like a new word to the LLM's vocabulary.
Okay.
But this isn't just any word. This is a conduit for visual information. A bridge between the LLM's text-based world and the visual expertise of those foundational models.
So it's like this HYBNET token is like constantly whispering to the LLM, hey, remember what MIMIC-CLIP taught you about how a cat actually looks?
You got it. Don't forget the big picture.
And what's amazing is that this approach lets us leverage the power of LLMs for image generation without needing to fundamentally change how they work, which is huge in terms of making this technology practical and accessible.
That makes a lot of sense, but does it actually work? Like, did they get good results with this whole ARRA setup? Well, they put ARRA to the test on several data sets, including medical images and ImageNet, which is this massive library of everyday objects. And they use metrics like FID and CLIP score to evaluate the generated images. And basically, the higher the score, the better the image. And guess what? ARRA consistently beat out existing methods, meaning that it created images that were both realistic and accurate to the text descriptions.
That's pretty impressive, especially when you're talking about something like medical imaging, where accuracy is super important. So they use these different foundational models as the tutors. How did that affect the results?
Yeah, that was actually a key finding. It turns out that if you're generating medical images, using a model that's been trained on medical data makes a world of difference, like having a specialist on board. They highlight how crucial it is to choose the right foundational model for the job.
Like you wouldn't ask a math tutor to help you with your history.
Exactly.
It makes total sense, but I'm still curious about those fragmented outputs they mentioned, where things kind of end up in weird places.
Right, they give this example of like an AI generating an X-ray where the ribs aren't connected properly.
Oh.
And this happens because traditional LLMs tend to focus on tiny chunks of an image without understanding the overall structure.
So it's like trying to assemble a puzzle, but only looking at individual pieces without seeing the picture on the box.
Perfect analogy. And ARRA tackles this by constantly reminding the LLM about that big picture context through that HYBNEXT token, ensuring that the final image makes sense visually.
Pretty cool.
Yeah.
It really is.
It is.
It really is. This whole idea of teaching machines to see is fascinating, but it's clearly not as simple as just throwing more data at the problem.
Exactly.
Yeah.
The paper really emphasizes that simply making LLMs bigger won't just magically solve the issue of generating these coherent images. It's not just about size, it's about the kind of learning that's happening.
So even with all the data in the world, an LM might still create like images where a cat's legs are bending the wrong way or objects are floating in midair. It's not just about recognizing what's in the image. It's about understanding how it all fits together realistically.
Yeah, that's why this concept of representation alignment is so important. It's about making sure that the LLM's internal understanding of an image matches the reality of how things, actually exist and interact visually in the world.
So that's where those foundational models come in, right? They act like a guidebook for the LLM.
Exactly, like a visual dictionary that says, hey, this is what a hearse's skeleton looks like, so make sure its legs bend the right way.
Right, but couldn't that be a problem? I mean, doesn't the LLM need to learn to see for itself if it's always relying on these external models? Could that stifle its own creativity?
That's a great question, and it's definitely something that researchers are exploring. It's all about finding the right balance. ARRA uses these foundational models as like a starting point, a way to give the LM a solid visual foundation. But the goal is for the LLM to eventually kind of build upon that knowledge and develop its own unique way of seeing the world.
So it's like giving an art student, a strong understanding of anatomy and perspective, but then encouraging them to develop their own artistic style.
perfect analogy, and the paper points out that timing is really crucial here. Aligning those external representations early in the LLM's learning process is key for the best results.
So you're saying it's like teaching a puppy new tricks easier than trying to change the habits of an older dog.
Right.
But how does that actually work? How do they integrate those visual lessons early on?
That's where our little friend, the HYBNEXT token, comes in. Again, remember how it acts as a bridge between the LLM's word-by-word thinking and the visual expertise of those foundational models.
Yeah, that's what makes it so cool. It's like having a constant reminder, ensuring that the LLM doesn't stray too far from visual reality.
Exactly. And what I find particularly interesting is that the researchers tested ALA on both natural images and medical images, which suggests this approach could be pretty versatile.
So whether it's a photo of a sunset or an X-ray of a broken bone, AL could help the LM make sense of it.
That seems to be the case, and the fact that they saw significant improvements in both domains is really encouraging. It means that ARRA isn't limited to any specific type of image. It's a framework that could potentially be used for all sorts of visual applications.
The paper also mentioned different ways to integrate these visual representations. Didn't they try using a fixed token at the start of the sequence versus using this dynamic HYBNEXT token throughout?
Yes, they compared using a fixed token, which they call REP, versus the HYBNEXT token, which is kind of sprinkled throughout the process. And it turns out HYBNEXT consistently produced better results.
I wonder why that is. Is it because that initial visual information from the fixed token gets lost as the LLM churns through more and more tokens, like it gets distracted along the way?
That's a really good way to think about it. They call it attention decay. Using HYBNEXT throughout the process ensures that every step is guided by that global to visual context. It's like having a constant visual compass.
So it's not enough to just give the LLM a visual guidebook. It needs to be constantly reminded of those visual rules in order to create a realistic image.
Right.
That's really insightful.
And it highlights the importance of not only providing the LLM with the right visual knowledge, but also making sure it's effectively using that knowledge throughout the entire image generation process.
Okay, but even with these advances, surely there are still some questions to be answered. Are there limitations to this ALRA approach?
Of course, no single research paper is the be-all and end-all. One thing that kind of jumps out at me is that the paper really focused on generating images from text prompts. But what about other types of input?
Like what? Give me an example.
Well, could ARRA be adapted to generate images from, say, audio descriptions or even music? Could we hear a symphony and have an AI translate those auditory sensations into visual art?
Whoa, that's a wild thought. It'd be like those visualizations you sometimes see accompanying music, but generated directly by AI based on the sounds.
Exactly. Or imagine generating images based on tactile data. Could we create visual representations of how different textures feel?
That would be incredible. Artists and designers could explore a whole new dimension of sensory experiences. But this isn't just about art, is it?
You're right. Think about science. We could generate visual representations of complex scientific data, making it more accessible and intuitive. Or think about education, creating personalized learning experiences tailored to an individual's unique learning style.
So we're not just talking about cool pictures. We're talking about using AI to change how we understand and interact with information across all sorts of fields.
Now you're getting it. And that's what makes this research so exciting. It has the potential to unlock a whole new way of thinking about AI, not just as a tool for automation, but as a partner in exploring the world around us.
This deep dive has definitely got my mind racing with possibilities. What else is brewing in your brain?
Well, all this talk about AI seeing the world got me thinking about a bigger question. What does it actually mean for an AI to understand something visually?
Ooh, now that's a deep one. We keep using words like understanding and coherence. But are we just projecting human qualities onto the AI? Is it really grasping these concepts the way we do?
That's the heart of the matter, isn't it? On the one hand, ARRA clearly demonstrates an ability to learn and apply visual rules. It can generate images that are anatomically plausible, follow the laws of physics, or even match the style of a specific art movement.
So it's showing a kind of visual intelligence, even if it might be different from how humans see things.
Exactly, and that's what's so fascinating. This idea of intelligence might have many different forms, both in living beings and in artificial systems.
Yeah.
ARRA, by imitating certain aspects of human visual understanding, might actually help us better understand our own brains.
That's a mind-blowing thought. By studying how we teach machines to see, we might learn something new about how we see.
Now you're getting it, and this brings us back to that question about generating images from abstract ideas. If we want AI to genuinely understand emotions like joy or loneliness, it might need more than just a visual rulebook.
It would need a model of the world that goes beyond just shapes and colors. It would have to include an understanding of emotions, social cues, maybe even cultural differences. That's a tall order.
It certainly is. It would need to grasp how emotions are expressed, not just through faces, but through body language, color choices, composition, even the subject matter of the image. It's a multi-layered problem, far beyond just copying visual patterns.
That's where things get really exciting. We're not just building tools, we're creating AI that can engage with the world on a much deeper, more meaningful level.
I couldn't agree more. And while this particular paper focuses on images, the implications of ARRA could reach far beyond this idea of aligning an LLM with external knowledge. Sources could revolutionize all sorts of fields.
I'm picturing AI composing music that perfectly captures a specific emotion, or designing scientific experiments that push the boundaries of knowledge, or even writing stories that resonate deeply with human experiences.
The possibilities are truly limitless. This research shows that we're just scratching the surface of what AI can do, and the journey ahead is going to be full of incredible breakthroughs.
This deep dive has been amazing. I'm honestly awestruck by the work these researchers are doing, and I'm so excited to see what the future holds for AI.
Me too. And for our listeners out there, we'd love to hear your thoughts. If you could ask an AI to create an image of any concept, abstract or concrete, what would it be? And what would you hope to learn from its interpretation?
Yeah.
Let's keep the conversation going.
Absolutely. Until next time, keep exploring, keep asking questions, and keep diving deep. Okay, so we've covered like a lot of ground here, from the technical details to some pretty philosophical questions.
Yeah.
But there's one thing that keeps coming back to me, and it's this idea of using AI for more than just generating pretty pictures. You hinted at it earlier, but I want to kind of dig a little deeper.
Well, what's fascinating is that while this paper really focuses on images, the underlying principles of this whole ARRA approach could have much broader applications. Think about it. We're essentially teaching an LLM to bridge the gap between its internal language-based world and the external world of visual information.
So it's like we're giving it a new sense of way to like see the world through the eyes of these expert AI models.
Yeah, exactly. And if it worked for visual information, why couldn't it work for other types of data? Imagine using ARRA to help an LLM understand and generate music.
Okay, now you're really getting my imagination going. Instead of text prompts, you'd feed it like a melody or a rhythm, and it would create a whole composition based on that.
Precisely. Or think about scientific research.
Yeah.
What if you could describe a complex experiment to an AI, and it could not only understand the concepts, but also design the experiment itself, taking into account all the necessary variables and controls?
Wow, that would be a huge game changer for scientists. It would free up so much time and brain power to focus on, the bigger picture questions.
Right. And on a more personal level, imagine using ARRA to help AI write truly compelling stories.
You mean stories that aren't just grammatically correct, but actually resonate with like human emotions and experiences?
Exactly. Stories that tap into our shared understanding of joy, sadness, love, loss, all the things that make us human.
That's an incredible thought. It's like we're on the cusp of a whole new era of creativity where AI can partner with humans to explore and express the full range of human experience.
I think you're absolutely right. And what's so exciting is that we're just at the beginning of this journey. ARRA is a powerful reminder that we're constantly pushing the boundaries of what AI can do.
This whole deep dive has been a real eye-opener. It's made me realize that AI isn't just about automation or efficiency. It's about expanding our own capabilities and understanding the world in new ways.
Couldn't have put it better myself. And this is why we do these deep dives, to explore the cutting edge of AI and to spark these kinds of conversations. And for our listeners out there, we encourage you to keep thinking about these ideas. What are the possibilities that excite you the most? What questions are still lingering in your mind? Let's keep the conversation going.
Absolutely. Thanks for taking this deep dive with us. Until next time, keep exploring, keep questioning, and keep diving deep.